Hello, my name is Divansan and my register number is URK25CS1018. In this video, I'm going to explain a series of basic multi-threading programs written in the C programming language using the pthread library, which is widely used in operating systems to achieve parallel execution and improve performance. Multi-threading is an important concept because it allows a user to perform multiple tasks at the same time instead of executing everything one after another, thereby saving time and utilizing CPU resource efficiently. So, in the first program, we learn how to create a simple thread. We begin by including the header files studio.h for input and output operations and pthread.h for thread related functions. Then we define a thread function called welcome, which follows the standard thread function format that returns a void pointer and accepts a void pointer arguments. Inside this function, we print a welcome message and return null to indicate that the thread has completed execution. In the main function, we declare a thread variable using the pre-thread underscore t data type, which uniquely identifies a thread. We then create the thread using pthread underscore create by passing the thread ID default attributes the function to execute and a null argument. After creating the thread, we call pthread underscore join so that the main program waits until the thread finishes before terminating. This program demonstrates the basic steps involved in creating and synchronizing a single thread. So, in the second program, uh, we understand how the main thread and outside thread work together. Here, the main function first prints a message indicating that the main thread is running. After that, we create a child thread that executes a message indicating that the main thread is running. After that, we create a child thread that executes a separate function printing another message. Since threads waits for the child thread to complete, this program demonstrates concurrent execution and coordination between threads. So, in the third program, we expand the concept by creating multiple threads that executes the same function. We declare two thread variables and create two threads using thread underscore create, both pointing to the same thread function. Each thread independently runs the same code and prints the same message, which shows how multiple tasks of the same type can be processed simultaneously. We then use pthread underscore join for both threads to ensure proper synchronization before the program exits. This demonstrates the parallel execution using multiple threads. So, in the fourth program, we further extend the idea by creating multiple threads that execute different functions. We define separate thread functions, each printing different messages, and then create two threads so that each performs a unique task. After creating them, we use the p thread underscore join to wait for both threads to complete. This program demonstrates two multitasking where different operations run in parallel, which is a key feature of modern operating systems. So, in the fifth program, we learn how to introduce a delay inside a thread using the sleep function, which requires including the UNI std.h header file inside the thread function. We call sleep for a few seconds to pass execution and then print up message. Once the thread wake up, in the main function, we create the thread and use pthread underscore join to ensure that the main program waits until the delayed thread finishes execution. This program shows how timing control and synchronization can be managed in multi-threading applications. So overall, this programs together illustrate fundamental multi-threading concepts such as thread creation, concurrent execution, synchronization, running multiple tasks simultaneously, handling different tasks in parallel, and controlling execution time. These concepts are very important in operating system and real world applications because they help improve efficiency, responsiveness, and overall system performance. Thank you.